I'm a space enthusiast in general, and so I'm here to learn and to meet people and network and see what any of us can do to help further the advancement of humanity into a spacefaring future. That was the general answer. The specific one is I did give a couple of presentations. I gave a presentation Thursday and one Friday in two different tracks. On Thursday, I talked about how to capture an asteroid into Earth orbit. And on Friday, I talked about how to use that captured asteroid to build a constellation of solar power satellites and the first orbiting habitats for people, which in my case are the workers used to build the the solar power satellites.
Tell us a little bit about the concept of capturing an asteroid. That sounds like pure science fiction.
Well, it's luckily not pure science fiction. It's a difficult thing to do because asteroids are huge. The specific asteroid I'm proposing that we capture is the asteroid Apophis, which is going to make a nice close approach to the Earth on Friday the 13th in April of 2029. It's going to swing by the Earth closer than our geostationary satellites. The geosynchronous satellites are 40,000 kilometers out. This is going to come by less than 30,000 kilometers away. So it's inside those orbits. And the Earth's gravity, when it comes so close, is going to greatly modify its orbit. It's going to swing out about 3 kilometers per second faster, and it's change its angle entirely by 28 degrees looping around the Earth. The key thing is we really don't know where it's going to go afterwards because tiny changes in where it goes through make a huge difference. They're worried about a keyhole, that if it hits this one particular keyhole that's only 600 meters across, Apophis will come back and could hit the Earth in 7 years, in 2036. That's a small keyhole, but it's possible. The key thing is small changes can make a big difference in where it is. And what I'm proposing we do is to go out, slow down this huge asteroid by only 200 seconds so that the Earth is 6,000 kilometers further along in its orbit when Apophis reaches that point. So it's moving it farther away. The net effect is Earth will not accelerate it by 3 kilometers per second, but will only accelerate it by 1.5 kilometers per second, which changes the orbit enough so that a year later it can swing by the moon, and the moon's slingshot around the moon will drop it into Earth orbit at that time. So in April of 2029, of 2030 is when it would go into orbit. The wonderful thing here is that if we capture Apophis into Earth orbit, we will have 27 million tons of resources where we can fly up, smelt, mine it, turn it into steel and magnesium and aluminum and silicon and oxygen, lots of oxygen. It's more oxygen than anything. And use that to build habitats, to build solar power satellites, we'll even have oxygen to burn. If we had converted the entire asteroid, just smelted the iron ores into steel, we will release over 1 million tons of oxygen, which is thousands of times more than we need to breathe up in the habitats that we could build. And hey, that's rocket fuel. Oxygen is rocket fuel, and 1 million tons, that's incredible. So that's what I'm hoping to do, is I'm hoping we can find a way to actually capture that asteroid, 19 years from now, and advance humanity by solving the energy problem. If we build 100 solar power satellites at 5 gigawatts each out of this thing, you've replaced 25% of the coal and oil burning plants on the Earth. That's a big difference. So there's a lot of green in this, where we can make a huge difference on global warming and on low-cost energy. And a little side thing. If you sell the energy from these solar power satellites at only 3 cents per kilowatt hour, which is the wholesale price, cheaper than coal, cheaper than nuclear, 3 cents per kilowatt hour. Each 5 gigawatt satellite generates $1.3 billion a year in revenue. And Apophis is big enough to build 150 of those. That's practically $200 billion a year of energy revenue. So whoever does this will get rich. So.